As highway mileage and vehicle travel have increased, so have collisions with roadside structures. By the mid-1960s, with the enactment of the Highway Safety Act, research and development was initiated with the goal of saving lives on our nation's highways. One of New Jersey's many contributions to this goal was the development of the New Jersey Breakaway sign support system for large ground-mounted signs. The concept of the New Jersey Breakaway sign support system is based on two components at the base of the support post. These are the breakaway couplings and the load concentrating washers. The LC washers are designed to ensure the sign structure withstands normal wind loads, yet allow the couplings to break away when the post is struck by a vehicle. The breakaway action of the system can be seen in this film clip of a full-scale crash test using an 1,800-pound Honda Civic. The test demonstrates that the system complies with the latest safety requirements for highway appurtenances and resulted in minimal damage to the vehicle and sign components. The support post is being prevented from flying completely free of the sign structure by a steel cable attached to the back of the sign panel. This cable is part of a shock-absorbing device installed within each support post. To ensure that the system affords the maximum level of safety to the motoring public, it is crucial that proper construction and maintenance procedures be followed. This videotape will give you an overview of the procedure used to assemble a New Jersey Breakaway sign support system. The accompanying manual will provide you with more detailed information regarding the design, function, and construction of this system. Installation of the breakaway sign structure normally begins with the construction of the footing and installation of the anchor bolts. We'll begin here with the placement of the leveling pan. Once the pan is positioned, the breakaway couplings can be installed. A lubricant is first applied to all threaded connections to facilitate the installation and future removal. The breakaway coupling fits on the anchor bolt only one way, with the small end of the taper pointing downward. When a wrench is used to screw down the couplings, make sure that only the lower wrenching flats of the coupling are used, as shown here. The top of the couplings are leveled using a carpenter's level. The level should be laid crosswise, lengthwise, and diagonally over the couplings. Rotate each coupling until all four are perfectly leveled. The hex studs are now screwed into the top of each coupling. Since there are four sizes of hex studs used with the breakaway design, make sure the correct one is installed. Before continuing with the installation, confirm that the hex studs will fit loosely through the post base plate. The holes in the base plate are sufficiently oversized to ensure a loose fit even when the anchor bolts are not perfectly aligned. A tight fit indicates that either the anchor bolt alignment or base plate holes do not conform to the plans. The problem must be corrected before continuing further. Once the fit has been checked, the leveling pan can be filled with grout and contoured to the shape of the pan. The sloping surface of the grout is designed to move the base of the post upward and outward away from the vehicle when the post is hit. Care should be taken that the narrow section of the coupling is free from grout. The lower set of LC washers are now installed. There are 4 sizes of washers used in the Breakaway design. Each is identified by a number, as seen here in the lower left corner of the washer, and a corresponding color code on its side. This washer is a number 3 and is coded blue. The raised shim portion faces down in contact with the coupling, and the arrow imprinted on the washer should be pointing towards the post. Washer retainers are now placed in the grooves of the front and rear set of washers. It may be necessary to adjust each stud to allow the washer retainer to fit. The support post can now be installed, but first we'll take a look at the assembly of its components. The shock absorber device mentioned earlier is inserted through a slot in the bar welded across the top of the post and is pulled through a hole in the base plate of the post, where it is secured with a lock washer and a nut. For now, just turn the nut on part way, and we'll get back to it later. A cover plate is secured to the top of the post to keep out rain, snow, and debris. The post to side panel connecting plate is now secured to the channel frame assembly by means of a U-bolt. The channel frame is then positioned over the post as shown, with the shock absorber cable on the side of the channel frame next to the sign in the finished assembly. The pin mounted at the top of the post fits into the hole in the connecting plate. A 2-piece collar is now bolted to the post tube just below the bottom of the channel frame. The small tab welded to the front half of the collar is positioned in front of the larger tab riveted to the bottom of the channel frame. These overlapping tabs prevent the bottom of the side panel from swinging forward in high winds, but do not interfere with the breakaway function. The shock absorber cable is now looped over the round bar bolted between each pair of channels. The cable is snugged as much as possible and secured with 3 wire rope clamps. The nut at the bottom of the shock absorber is now tightened using a wrench, further snugging the wire rope loop at the top. The cable should be snug enough to ensure the post top pin and plate remain connected during assembly, but not so tight as to activate the shock absorber. With the channel frame firmly attached, the post is lowered over the hex studs, coming to rest over the top of the lower washers. Care should be taken to ensure that there is no lateral pressure put on the couplings. The upper set of LC washers are now positioned, with the eccentric shims now facing upwards, but the arrows still pointing towards the post. Hex nuts are now placed on the studs and tightened. The coupling should be held by a wrench spanning the upper wrenching flats only. There is no torquing requirement. The nuts should be just snugly tightened by the turn of the nut method. Post base shields are bolted to the front and back of the post base. These shields protect the exposed hex stud threads in the event of an impact. The sign panel is now ready for installation. Sign panel clips are inserted into each panel groove and staggered between each side of the channel frame as detailed on the plan sheets. The entire sign panel is then lifted against the channel frames. Make sure the sign panel is evenly spaced between the posts. The sign panel clips are then pushed against the edge of the channel frame and tightened with a wrench. Once the sign panel has been secured to the frames, a hole is drilled through each post collar and a blind rivet is inserted to keep the collar in place. The installation is now complete. No regular maintenance will be required. Repairs will be made as necessary if the structure is hit. When an impact does occur, the sign will most likely remain supported by the unimpacted post. Repairs after an impact typically will consist of replacing not only the broken couplings, but the unbroken ones as well, since they may have developed minute cracks during the collision. The internal shock-absorbing devices are removed from each post and inspected for slicing. In most cases, only the shock absorber from the impacted post will need to be replaced. The post collar and channel frame tabs should also be inspected after each impact. Occasionally, either of these tabs may break off during the collision. During 14 years of use in New Jersey, at least 50 breakaway signs have been hit. About half of these accidents have been documented by police reports, but in only 5 cases have there been injuries reported, and these consisted mainly of scrapes and complaints of pain. With the improvements recently made to the system, an even greater level of safety is anticipated. Full-scale tests conducted also indicate that the modified design should function with less hardware damage, resulting in reduced downtime. For additional information and details regarding the New Jersey Breakaway Sign Support System, please refer to the implementation manual accompanying this videotape. This technology transfer presentation was prepared by the New Jersey Department of Transportation Division of Research and Demonstration with the assistance of the FHWA New Jersey Division Office.